Hi guys, so here we are with class number 6. So our aim is to cover spare parts management here. So in this class we can complete study note number 7. So the main topics covered are spare parts management and the problems associated with it, and one very important problem which you can get for 8 marks, okay, which is the individual replacement and group replacement problem. That is the last problem of the study note. Okay, it may be bit confusing in your book, but it's explained well in this video. So please watch this video, and in the next video we will be releasing on simulation, guys. Okay, so please comment wherever you have a doubt, and in case if you want to share this video to your friends, please share the links to your friends, and please subscribe to channel so that all the upcoming updates you will get in your email ID. Okay, so stay tuned guys, we will go on with the class now. Hi all, so today we are here with spare parts management. So this is from study note number 7. This is the second part. Initially we saw maintenance management, where in maintenance management we saw about the breakdown maintenance and preventive maintenance and associated problem. So guys, don't forget to work out illustration number 4. Okay, even before the exams you just work illustration number 4. It has a value up to 8 marks. Okay, so guys, so this is the spare parts management. In spare parts management we have a problem which is very similar to illustration 4, but the formula should not be confused between the illustration 4 of maintenance management and this problem of spare parts management. I will say you the differences clearly. So we can go on with the class, guys. So spare parts management is nothing but, so what is the spare parts? Here it means that it is the spare parts of your plants and machinery. Okay, so you have a plant and machinery which is making your product, and we are doing the maintenance for that plant and machinery. Initially we saw about what is breakdown maintenance. So there the repair happens, and then we will and then the breakdown happens, and then we will repair the machine to make it run. Okay, and in between the breakdown maintenance, the labor will be idle and the whole production will be idle. Okay, and we come across something new called preventive maintenance, where we are not avoiding the breakdown, but we are installing some preventive maintenance, proactive maintenance approach, whereby we are reducing the number of breakdowns happening. Okay, so that is the preventive maintenance. So for all these two, breakdown maintenance or preventive maintenance, we need to store all the spare parts of the machines in a warehouse. Okay, and managing that spare parts inventory is called spare parts management. Okay, it is categorized into two main groups. One is fast moving spare parts and slow moving spare parts. Okay, so what is fast moving is nothing but rotable spares. Okay, you can see here rotable spares. They are periodically changed because for example, if there is a machining process going on, okay, metal is produced and the metal is getting machined. Okay, the drill bit will face the wear and tear, and it should be replaced every day. Okay, so this is a normal wear and tear part, so this will be periodically changed, and you need to have spares for this. So this is rotable spares, and these spares are very fast moving. Okay, but however some spares are slow moving. Okay, when that is used, maybe if you are using breakdown maintenance, the breakdown happens, then you will be using those spares. Or in the preventive maintenance, you are doing a proactive approach. At the time you find that, oh my god, this part of the machine is so weak that there is a high probability you may end up in a breakdown in 1 or 2 weeks. So let me replace this item with a new one. So only in rare occurrences the consumption, these spares will be consumed. So those are slow moving parts. So those are slow moving parts. So examples of slow moving parts are this insurance spares and capital spares. So what is regular spares? Regular spares is required regularly. So the stock of which should be kept regularly. So
it's almost similar to rotable spares, but rotable spares you have a periodic time during which you need to replace, but regular spares they will be used regularly, but it is not having a periodic interval. So that is the difference between regular spares and rotable spares. So guys, for regular spares a small formula is given in the question for service level. For service level is nothing but you are maintaining the spares inventory using the regular spares mechanism. So if you maintain that, what is the service level achieved? Service level is nothing but how it has met our requirement. Okay, so for that a formula is given in your book. As for the regular spares, service level is nothing but Ku divided by Ku plus Ko. So what is Ku and what is Ko? Ko is nothing but opportunity cost of overstock. So you have overstocked the spare, okay, which means money is locked up, your working capital is locked up in the form of spare, which means you will have a financing cost associated with it. And Ku is nothing but the opportunity cost of understock. So when you have a understock, there is a high probability that during the breakdown you will not have the spare, and your labor and machines everything will be in idle. Okay, so X is nothing but the amount which is stock, the stock which you have in your warehouse, and Y is the demand for the item. So f of y is nothing but how the demand varies, the function of y, how the demand varies over the time. Okay, so here we take it as the total cost. Total cost is nothing but overstock, opportunity cost of overstock. Okay, opportunity cost of overstock. So during the overstock your stock will be higher than demand, so x minus y f of y dy. And during understock, opportunity cost at understock is nothing but Ku, and during understock your demand will be higher than stock, so y minus x f of y dy. So if you just differentiate and equate it to 0, you will just achieve the what is the minimum total cost to the company for meeting the service level. So for the service level, to calculate the service level, the formula derived, this is a derivation which is not given in the book, but this is useful for you guys because it may be asked in the objective type question. Okay, so you land up in a formula called Ku divided by Ku plus Ko. Okay, so you know what is Ku, what is Ko, so you can just find it. So they may give a value in the objective type question and they may ask you to calculate what is the service level. Okay, so remember guys, have this formula in mind. This is yeah, important objective marks objective. You may get 2 objectives out of it. So next is insurance spares. So insurance spares is nothing but spares I hold in a spare part inventory. Okay, but I would not use in the normal course of because it's a very rare occurrence. Changing of this kind of spare is a very rare occurrence, but surprisingly if this is not available and our machines are breakdown, it will cause significant loss. So it is always better to store this as an inventory, and since it has a very high criticality and very high risk, we call it as insurance spares. Next is capital spares. All these spares have very long life and has a very small chance of failure. Would cause a small, okay, and if it is failed it cause a long shutdown, so the period of shutdown will be very high. In the insurance the cost or impact of the shutdown is very high. So in the insurance we see that cost of the shutdown is very high, impact of the shutdown is very high. However, in the capital spares it will cause a longer duration time. Okay, so that's called capital spares. So these are the different spares based on the service level guys, and only for one type of regular spares we derived a formula here. Okay, so moving to the next slide. So we have come under the problems. So what does this say is compute the requirement of spares for the breakdown. So we need to compute the requirement of the spares for breakdown maintenance for the item that exhibits Poisson behavior. Okay, so guys, you know logarithm has a logbook. So similar, one of the distribution is Poisson distribution. So Poisson distribution also, they will have a Poisson distribution table, and when this question comes in your exam, you need to ask your examiner for the Poisson distribution. Okay, so I have given the snapshot of Poisson distribution here. So Poisson distribution have demand in this axis, and that is called as K, and lambda in our axis, and this is called as consumption. So this is called as consumption. So demand and consumption is given, and this is the Poisson distribution. So I will go on with the question. Okay, exhibits a Poisson behavior for failure rates with a mean breakdown rate of 5 times per month. So the breakdown is going to be 5 times in a month, and that is a mean breakdown. So which means average consumption for every month spare is going to be 5 numbers. So I take this as the mean consumption is going to be 5 numbers. So I am just locating 5 in my Poisson table, and my 5 is here. Okay, so I'm continuing with the question. If the lead time for procuring these spares is 1 month, so lead time is 1 month, and the service level is 90 percentage, is it okay, is it to be used, service level of 90 percentage to be used, what is the buffer stock of these items should be maintained? So guys, 5 is the consumption, so of course I need to maintain 5 as my inventory, but there may be fluctuations in the demand, because we see only the average consumption or mean consumption is 5. So which means there may be sometimes above 5 and there may be sometimes below 5. So during above 5 you will end up in understock, and during below 5 as your consumption you will end up in overstock. Okay, so guys, we need to calculate what is the maximum demand, and when we calculate maximum demand, we can land up in the buffer stock to be maintained. So what is the buffer stock? The formula is given here. Buffer stock is nothing but the maximum demand during the lead time minus average consumption. Average consumption is given as 5. So what is the maximum demand? So here they have given service level as 90 percentage. So the data given here is service level, guys. All this data is nothing but the service level. Is nothing but the service level. So here if you can see in the when the consumption is 5, mean consumption is 5, you can see this as 7, it's moving as 0 0.007, 0 0.4, 0 0.125. So all these things, when it converted into percentage, it is the service level. So when I have demand as 3, it is going to be 26.5 percentage is service level, 44 percentage is service level, 61 percentage service level, 76 percentage service level, and I get 86.7 percentage service level and 93.2 percentage service level. So guys, it is given in the question that minimum you need 90% service level. So 93.2 is above 90. So I take my maximum demand as 8. So maximum demand for the given service level is 8. So the buffer stock will be maximum demand minus average consumption. Maximum demand is taken from the Poisson table as 8. 8 minus 5, it is 3. So 3 is the buffer stock. So guys, you may get this as a 4 marks question, but please demand Poisson distribution table from your examiner, because there is a chance that the values for the K or the average consumption would have been changed, and because the question paper is bit tricky, so they may change the numbers to a little bit. So you need to demand the Poisson distribution table. Okay, don't have these numbers in mind. So guys, moving to the next problem. So illustration number 6, the main shaft of the equipment has a very high reliability. So very high reliability in the sense the probability of breakdown is very less. So reliability is the opposite of breakdown. So I have 99% reliability, which means 1% chance of breakdown. Okay, so equipment comes from Russia and has a high downtime cost associated with it. So it has a very high reliability, but if it breaks down, it has a significant downtime cost. Okay, and what is the downtime cost? It is given as 2 crore rupee as the downtime cost. Okay, so next, this spares is quoted. Okay, so to reduce the downtime cost, I am asking a quotation for spares from the supplier. So supplier has quoted as 10 lakh as the cost of the spare. So should the shaft be procured? Okay, now I am buying the shaft. Should I buy, and should I buy or not? That is the question. So here if you see, probability of breakdown or probability of failure is 1 minus reliability. Reliability is given as 99%. So the probability of failure is only 1%. And if 1%, what is the cost? It is 2 crore. So probability multiplied by cost of breakdown. So the expected cost of breakdown is only 2 lakh rupee. So the cost of breakdown is 2 lakh rupee. But if I buy the spare, supplier has quoted as 10 lakh rupee. So the cost of breakdown itself is low. So better I will not store this item as a stock. Okay, so the supplier quote is significantly high. Why should I spend 10 lakh now? Instead, while the breakdown happen, I will spend 2 lakh, put the order to the vendor, and I will buy from the vendor. Okay, so guys, moving to the next problem. Illustration number 8. A firm is using a machine whose purchase price is 15,000 rupees and installation charge is 3,500 rupees and the scrap value is 1,500. Okay, the maintenance of various years is given below. So for all the years, the maintenance value is given below, and you can see that the value is keep on increasing every year. So every year maintenance value is keep on increasing, maintenance cost. Okay, so guys, they have given a purchase price of the machine as 15,000, and to install the machine you will spend 3,500, which means 18,500 rupees is the value of your asset or value of your plant and machinery, and you have a scrap value and 3, that is 1,500. So 18,500 minus 1,500, 17,000 is the value of machine. Okay, so I'm not going to consider this value of machine. Okay, so the maintenance cost, with the help of maintenance cost alone we can finish this problem. Okay, what is asked in the question is the firm want to determine how many years should the machine be replaced for the economic consideration. Okay, so on the machine replacement will be done at the year end only. Okay, so guys, the details question in the given in the question is from year 1 to year 9. So I have taken year 1 to year 9 here as my first column, and this is the maintenance cost. This is given in the question. This is the maintenance cost, and I'm just finding the cumulative maintenance cost, and I name the cumulative maintenance cost as CM. CM is the cumulative maintenance cost. So what is the average maintenance cost per year is nothing but the cumulative maintenance cost for every year divided by the respective year. So divided by the respective year. So that is the cumulative maintenance cost. So if I see the average maintenance cost, so what I do is this is the CM, which is the cumulative maintenance cost, and this is the year, nothing but the Y, and you can put the fourth column as CM divided by Y. Okay, that is the average maintenance cost per year. So you need to find CM divided by Y. Okay, so you will get the cumulative maintenance cost per year. Okay, when you get maintenance cost per year, and if you see the trend, the maintenance cost will keep on reducing from the month 1 to the 7th month, and on the 8th month you will see a sudden increase. This shows that the cost of maintenance per year is going up. from the 8th year onwards. So what is the minimum maintenance cost per year that is available in the 7th year? So the first year maintenance cost, the second year is low, the third year is still low, fourth year is still low, and if you go till 7th year you can find the minimum, and in the 8th year it is once again increasing. So guys, please watch this trend in the last column of the table given in your book. Okay, so the 7th year is going to have the least maintenance cost per year to the company, so it is advisable to replace the machine every 7th year. So every 7th year machine should be replaced. So guys, moving to the next problem. So guys, we are here with the last problem, which is illustration number 9. Illustration number 9 has same importance equivalent to illustration number 4. That it has a lot of similarity with the illustration number 4, okay, but there is lot of differences also. So guys, please watch this problem so carefully, and if you are lucky to get this problem, you may get up to 10 marks for this problem. Okay, so there is a high chance you may get this problem. Okay, so similar to illustration 4, here also we are going to compare between breakdown maintenance and preventive maintenance. Okay, so but we give different namings for them. Now we are going inside the problem. A large computer installation contains 2,000 components of identical nature which are subject to failure as per probability distribution as follows. So this is the probability distribution. You can see here till 100% it has come, so which means this shows that this is a cumulative value. So cumulative values is given here. Please check the problem, guys. Okay, it is a cumulative value. Okay, so from the cumulative value you can find monthly what is the probability. Okay, so components which fail or replaced for the efficient or replaced, guys. Okay, in the illustration 4 we saw it as repaired, but here it is replaced. Okay, so that's the important point, guys. If they are replaced, as and when the failure occur, the cost of replacement per unit is rupees 3. So for example, we have 2,000 components. Okay, as given in the question, we have 2,000 components, and if the 2,000 components, when they fail, I am going to replace with a new component. In that case, for per each component I need to spend rupees 3. So this is nothing but a breakdown maintenance, guys. So if you can see the similarity, whenever there is a breakdown, I am going to repair it. So similarly, whenever there is a failure, I am going to replace that component. Okay, so I have 2,000 components. Out of 2,000 components, while running in the first month, second month, some components will fail. During the failure of the component, I am going to replace that component. Okay, and when I do that, it is called 3. I am going to spend rupees 3 for each replacement, and this is called individual replacement. So what is individual replacement? Whenever there is a failure, I am going to pull the failed component out and I am going to fix the new component. For the new component to buy from the vendor, I will spend 3 rupees. Okay, alternatively, if all the components are replaced in one lot at the periodic intervals and individually replace only such failure that will occur between the group replacement, the cost for replacement is 1. So guys, now you can compare this with the preventive maintenance. Okay, preventive maintenance does not avoid breakdown, but it will minimize the breakdown. So what is the company's second policy is, okay, in the periodic interval, I am replacing all the 2,000 components. Okay, for example, monthly once or 2 months once, I am just replacing all the 2,000 components, and during this, and this is called group replacement, and during this also, while running, some breakdowns or some failures may occur. During the failure occurrence, I will replace the failed component alone. Okay, so initially we saw only the individual replacement. In the individual replacement, it is only the cost of the components, those are failed and replaced. Only the cost of that is there. But when you come to group replacement, you have a group maintenance policy. It's nothing but a preventive maintenance policy, plus there are few breakdowns, and to replace the breakdown also you are expending some cost. But the advantage is, if you do this, supplier is willing to give you for 1 rupee. Each component for 1 rupee. Initially he supplied for 3 rupees. So what is the question? Assess which policy of replacement is economical. Okay, so guys, if you can see, it is the same way we are going to approach this. So average month for 100% failure to occur is nothing but sum of product of month multiplied by probability. So probability is given in the question, guys. For the first month, what is the probability? What is given in the question is cumulative. So the second month minus first month the probability is going to be 10%. The first month probability is nothing but 10%. For the second month, it is second month minus first month, which is going to be 25 minus 10 is equal to 15%. So guys, just have that in mind. So probability, this is the cumulative probability. From the cumulative probability, you need to find monthly probability. So monthly probability, I call it as MP. From the cumulative probability, you need to find the monthly probability, and monthly probability multiplied by the respective month, and totaling that you will get average. So this is similar to the illustration 4, guys. So you get in 3.35 months, there is a chance for 100% breakdown. Okay. So in the question, cumulative probability is given. Find the probability, monthly probability, and apply the formula. Okay, so next, average monthly replacement is going to be, you have 2000 components and divided by 3.35. 3.35 is nothing but average month for 100% failure. 2000 divided by 3.35, monthly there are going to be 597 failures. So out of 2000, monthly there will be 597 average failures, and all the failures, only the failed components you are going to replace, which means this is called individual replacement. So the cost of individual replacement, during individual replacement, supplier will supply only for 3 rupees. So I have applied 3 rupees here. Okay, and 597 multiplied by 3 is 1791. So guys, the first policy is individual replacement. Now we have got the cost of individual replacement. So guys, now we need to proceed with group replacement. Okay, it's bit tricky, but it is not difficult. Okay, so guys, here you can see the formula. So the formula is nothing but, for 2000 components, the first month probability is 10%. So I call the probability for the month 1 as P1. So monthly probability is nothing but P1 to 5 months are given. So P1 to P5. So P1 to P5 are monthly probability. So you can see the formula here, 2000 pieces multiplied by P1. Okay, and for the 2000 pieces, it is the second month. But in the second month, what is the, okay, during the first month, you have 2000 multiplied by the probability of 10%. So number of failures is 200, and number of replacement, whenever there is a failure, you are going to replace in the group replacement, as well as you are going to maintain a preventive maintenance policy. So there is 2 costs, and sum total of these 2 costs is going to be the cost of group replacement. Okay, so now I want to find what is the number of replacements I am going to do each month. Okay, because every month there is going to be some breakdowns or some failures, and I will replace that. Okay, and I will replace that. Okay, so here if you see, in the first month, out of 2000, 10%, 200 has gone. So 200 I have put new new components. Okay, 200 new component. I have taken out the 200 failed components from the batch, and I have replaced with a new 200 new components. So for the 200 new components which are replaced in the month 1, the probability is the first month is going to be the second month. So 200 multiplied by P1 and 2000 multiplied by P2. Sum of these two is going to be the number of replacement I am going to do in the month 2, which is 320. So for the 320 I am replacing in the second month. Third month is going to be the first month for them. So 320 multiplied by P1, and for 200 items which are replaced in the first month, this is the second month. So 200 multiplied by P2 and 2000 multiplied by P3. So this is a very simple formula, guys. Just extrapolate this formula and find the number of replacement and find the cumulative number of replacement. So you have done, you have found what is the replacement for each month. Now you are finding the cumulative replacement, and all this replacement will be done at 3 rupees per unit, because supplier has quoted for individual replacement I will always give at 3 rupees only. Okay, but here we have installed group replacement policy also. For group replacement, every month I am just assuming that every month I am going to replace it, and 2000 multiplied by 1, so 2000 is consistent monthly cost. Okay, and the total cost is nothing but the cumulative replacement cost plus the group replacement cost is going to be the total cumulative replacement, total cumulative cost, and you can divide by the respective month to find the monthly maintenance cost. Monthly maintenance cost is found. Guys, once again here you can see in the first month the cost is 2600. It is going down in the second month. It is still going down in the third month. From the fourth month it is reversed and it is increasing. So guys, the minimum cost is on the third month. So third month has the lowest cost, lower than the individual replacement. So for individual replacement we have 1791 per month, and for group replacement, when the group replacement is done 3 months once, okay, if 3 months once you are going to do the group replacement along with the individual replacement, okay, and that policy is going to fetch you only 1749 per month, guys. Okay, so our question A is answered. So what is the question A? Assess which policy is economical. So the economical is group replacement policy combined with the individual replacement policy, and the group replacement is done in 3 months once. So once in 3 months group replacement is done, and that is the most economical. So group replacement is beneficial when it is done 3 months once, guys. So guys, what is the next two question? Okay, now we have understood the fundamentals of the question. So answer to B and C is going to be very simple. If you study in your book, it is bit complicated, but it is very simple, guys. I am going to use the same table here. Okay, this is the same table. Month is taken as the first column. So here month is taken as the first column. For each month, what is the formula to find the number of replacement? So number of replacements, cumulative number of replacement. Cumulative number of replacement multiplied by 3 rupees is the individual replacement cost. For group replacement, what is the cost? Find the total cost, divide by the month, you will find the per month cost. Okay, the same table I am going to use, guys. So what is the question number B? If group replacement is economical at current cost, yes, group replacement is economical. That's what we found in question A. Then assess at what cost individual replacement would be uneconomical, would make group replacement uneconomical. Okay, so what they are asking is as per answer for the question A, okay, we have found that group replacement is beneficial. So they are asking me at what cost of individual replacement would be beneficial. Now what cost we have? We have 3 rupee per component as a individual replacement cost. So we should find some cost below 3 rupees at which individual replacement is beneficial. So understand the question properly, guys. Okay, so what is C? Question C is how high can the cost per unit in group replacement be to make preference for the individual replacement? So it is just a reverse of that question, guys. So now once again I am trying to make individual replacement as better. For making that, how much should be the cost of individual group replacement? So now what is the cost of group replacement? Cost of group replacement is nothing but 1 rupee. Okay, it is nothing but 1 rupee. If how high the 2000 rupees or 1 rupee can go, okay, how high the 1 rupee can go, so that individual replacement can be best. So what is question B, guys? In the question B, they have asked me that how much the individual replacement cost can be reduced from 3 rupees to find which is the to make the individual replacement as the better one. Similarly, how much high the group replacement cost of 1 rupee, okay, above 1 rupee, how much it must go so that individual replacement will be better. So in both the cases I should make individual replacement as the better case. So what is the relevant cost? Okay, so moving to the next slide. So here I am going to find the cost of individual replacement. So the same month I have taken, same formula, number of replacement is same, cumulative replacement is same, and cumulative replacement multiplied by 3 rupees, instead of 3 I have assumed K. Okay, so for group replacement it is going to be 2000 multiplied by 1 rupee, no change in this. So cumulative total cost is nothing but the sum total of these two column is taken here. Cumulative total cost. So total cost per month is divided by the cumulative total cost divided by the respective month. So here I have given as H is equal to G divided by month. So what is G? This is G. And what is month? This is month. Okay, so you are dividing by this. Okay, and for individual replacement, so guys, individual replacement we calculated the cost 597 is the average replacements done during the breakdown stage, which we during the beginning of the problem we calculated, multiplied by 3 rupees we did. So similarly, individual replacement cost is 597 multiplied by K. So guys, I am just equating these two columns. Why I am equating? I am just equating to find the value of K, and that value of K will make my group replacement cost equal to individual replacement cost. So if I equate these two columns, okay, so I am just equating these two columns, okay, and I find, of course, the third month will have the lowest, because already we have seen the third month has the lowest cost of group replacement. And when I equate these two, I find the value of K, and value of K is 2.82. So guys, the individual replacement cost given in the question is 3 rupees, and from 3 rupees if it starts reducing, and any value of 2.82 and below, okay, individual replacement will be good, guys. Okay, group replacement will be uneconomical. Okay, so answer to question A was group replacement is beneficial. Question B is in what cost of individual replacement will be beneficial. So when the cost of individual replacement goes below 2.82, individual replacement will be beneficial. So guys, we are going to C. We are going to question C. So question C, the same month I have taken, same formula, number of replacement is same, cumulative replacement is same. Here I can take 3 rupee as the cost. Okay, so here group replacement 2000 multiplied by 1 rupee. Instead of 1 rupee, I have taken this as A rupees. Why I have taken A, guys? So here the question is, in what cost of group replacement individual replacement will be beneficial? Right now what is given in the question is 1 rupee. So if you increase from 1 rupee, at what point, okay, at what point individual replacement will be better? So that is the question, guys. So I am assuming 2000 multiplied by A, so that is constant for all the month. So now I am finding the same way, cumulative individual replacement cost plus group replacement cost is the cumulative total cost. I am dividing by the respective month. And what is the individual? 597 multiplied by 3, which is given in the question, 3 rupees. So I am equating these two sides. So when I equate both the sides, these two columns, I get the value of A. So what I get as the value of A, okay, what I get the value of A is nothing but I will get something above 1. Okay, so that is the cost. If you find the value of A is the cost of group replacement at which individual replacement would be economical. Okay, so guys, that is about this problem. This is very, very important problem, guys. Okay, so meet you in the next class, guys.
So guys, that's about the spare parts management. We have completed study notes number 7, and till now we have completed up to 30 to 35 marks of the total syllabus. Okay, including the theory part, which will come for objective question, as well as the problematic parts has been explained till now. So you are ready for 35 marks, guys. So next class will be on simulation, a very, very important topic, guys. It may take 2 classes, or I may complete in 1 class. Probably it may take 2 class. Okay, so stay tuned, guys. Meet you with simulation. I will ask you to just see an overview of what is simulation in your book. Okay, and class number 7 will be on simulation, will be released on next coming Saturday. Okay, yes guys, stay tuned.